It's kind of funky, that's why it's funky. Oh, come on, Jeff.
So we have to have the quiz corrections in by the day of the test?
By the day of the test. So these quiz corrections, if you want to do them, are due next Wednesday. I don't think I brought any blank copies of the practice test. Is anybody here not here last time didn't get the quiz? I can give you a copy of it at least so you can have it. See what it looked like. Quiz? No. I didn't bring any of the practice test. I've got the answer key, so I'll give that out here in a little bit. Yeah.
Are your tests timed too? Can you time them?
Say again?
Your tests, can you time them like you do?
Just within the frame of the class, but we have such a long class. I'm not going to make a test that's supposed to take 3-something hours. So I'll tell you that day how long I'm going to give you. It'll at least be a couple hours, but it's not going to be the whole time. Yeah.
And those
Sit up here.
dismissed
Dying.
early, or?
I'll tell you exactly how long you got. It's going to be at least a couple hours.
But we'll have most of the class, right?
Say again?
We'll have most of the class.
That's all we'll do that day.
Oh, okay.
Yeah. Yeah.
So you're done and you're go home?
Exactly. Or wherever you want to go. You don't have to go home. You don't even have to go. You just sit here. Well, no, I'm sorry. I'm just messing with you because I'm evil. Yes?
Are you going to give us answers to the practice test?
Oh my goodness.
I don't know. Yeah. Thank you, people around him. So today is pure review day. We could do whatever you guys want to focus on. If you don't really have too many questions, you just want to attack your quiz corrections, feel free. If nobody's asking any questions, the floor is yours. You raise your hand, we do whatever the hell you want. Whatever you want to take a look at. Huh? Yeah, if you want to. So if you don't really have any questions and you just want to start attacking the practice test, you haven't tried that yet, you want to start working on your quiz corrections, you can do that.
We can ask you about this?
If you want some explanations of how the hell to do certain things, that's what I'm for. Yes?
63 on homework 2.1. It'll be page 150. It's not 151. No, it's 150.
60.
63.
63?
From 2.1.
Oh, yeah. So far away. So, guys, this is on page 150, number 63. And just so you're thinking while I'm showing you how to do this problem, an example of a good question to ask would be, how the hell do you factor cubes again, Jeff? We can do several. How do you do this kind of thing again? We can do several. I'm not going to do the ones that are on your quiz specifically because you can make corrections to them and I'm not going to do your work for you. Yes? This is page 150.
This like section 2.1?
Yep.
2.1, yeah. So this one says find the domain of this. What part of this function actually has nothing to do with being a problem with the domain? What part of this is really have no problems anywhere? The top. Two reasons. It's just a polynomial. They don't have any problems anywhere, and it's not in the denominator, so it's not going to throw a fraction off. It could do whatever the hell it wants to. I don't care. There's no inputs I can't put in there. So forget him. Obviously, the big problem, and it's got like 2 problems going on, which is crazy. The bottom of any fraction cannot be
0.
But this is even worse. In general, the inside of a radical must be
Positive.
or 0. Right? So now we say, because of the square root, this thing must be, how do you write it in math now? Greater than or equal to. But the fact that it's on the bottom tells me it can't be
0.
All right, there you go. So you've translated from English. It can't be 0, and it must be greater than or equal to 0. Okay, so that means take the equal to bar away. So now I can write it mathematically what I'm thinking English. Cool. That's how any domain works. Give you a function, what's the domain? You think, what are the restrictions on this in English? Let me translate them into Mathish. Yeah.
Can you do that again?
Sure. All right. So if I had this sitting by itself, to find the domain, I would say the inside must be at least 0. It can't be negative. For this specific problem, it's also on the bottom. It's also in the denominator of a rational expression, so it can't be 0. So the only adjustment I have to make, it still has to be positive, but now I just can't allow it to equal 0. You guys get that? So that's why this is a little more involved problem, because it's got two problems at once. It's on the bottom, can't be 0, and it's in a radical, can't be negative. Therefore, it must strictly be greater than 0. It must be strictly positive. Now, what do you do? To figure out what x can do, you just solve it, right? And that'll tell you exactly what x is allowed to do, or what values of x you're allowed to use. I want to put it better. So x has to be greater than 1/2. And you can always kind of test this out. If I put a 0 in there, it craps out. If I put a 1 in there, it's fine. So it certainly seems to be at least around 1/2 that the break-off is. So this makes sense. Okay.
And how do you write that out?
Just
The
like,
brackets, right?
yeah, however they just say find the domain. So actually this would be perfectly fine to put for the domain.
Okay.
If I'm more specific and I say, give me a visual of the domain, you have to do a number line, interval line. So if you had to, you could do 1/2. So 1/2 to infinity. But this is perfectly fine by itself to answer what is the domain. To answer a question, what is the domain, you have to tell me everything x is allowed to be. That's what this does. Yes, sir?
For 2.2, review question number 50, please. Piecewise.
And everybody's cool with this one? Is that right? Real quick, a little follow-up on this before. You said 55?
50.
50. So a little sidebar on this. Here's a really interesting problem. What's the domain of this guy?
Same.
Okay, I got one suggestion for all numbers. Everybody just saw me say to him, yes. The only problem with this, the bottom is a polynomial. They have no problems anywhere. The only reason it's making a problem is because it's in the bottom. And the bottom cannot be 0, and this cannot be 0 ever. What's the lowest number this could come out with?
1.
And we're always, when we're talking about domains, we're definitely talking about real numbers. Don't start throwing, well, if you throw in there I, screw that. We're talking about real numbers, right? We're not talking about over the complex rate number. So this guy would have all real numbers. You could throw anything you want to in here. It will never make this 0. Any real number, because that's what we're talking about. I would,
Funny R.
funny R? Yes. Funny R. You say all reals. Cool. If you say any number, I might have to be a real dork and say not a complex number. So you want to be, you say all reals. Cool. So not a big deal. I know what you meant. So section 2.2. Oh, cool. At this one, when they start throwing these things and turning them around on you, let's see.
What page is it?
Page 160. So they give you this graph. Wow, Jeff. and they ask you, now it's difficult enough sometimes, hopefully we're past that point. Piecewise functions should not be really difficult to graph, it's just like a few problems in one. It's easy to graph parabolas and lines and stuff. You just have to graph a few of them on the same graph, no big deal. This one is definitely a little more complicated. They give you the graph and they say, what must the function itself have been? The very first thing we can do for ourselves is identify the different regions that this is broken up to. What are the pieces? What's this piece? How can you say x what to define this? Yeah, so you go to -1 because it's got a closed circle there. What about the next thing? It's defined from this line. When is it a line? From what to what? A diagonal line. -1
-1
to 2, not including -1, right? Oops. Okay. And then when does this guy take over?
X is greater
Yeah,
than
exactly. X strictly greater than 2. So there's our pieces. Now we just have to define our functions on each piece. This one and this one, if you have trouble with that, I am concerned. Those are constant functions, so what is it back here? For any input here, the output is 1. Bam, right? For any input here, the output is -2. So the whole problem, really, that wasn't really all that evil. The whole problem with this is just figuring out the equation of that line. And you've got 2 points it definitely goes through. Define the slope, put it into mx plus b form, throw that in there, you're done. So let's see if we can do that. What points does it go through? What points does this line go through? Yeah, -1, 2, and 2, -1. Cool. So find the equation of the line that goes through those 2 points. That should sound familiar. It's not even saying that is perpendicular to this. It doesn't even say that.
Is it like the y1?
Yeah. What 2 things do I need? Whenever I teach my students how to find the equation of the line that does stuff, I tell them you need 2 things. What 2 things do you need? Slope. And point. We got this coming out of here, so let's just pick one. I'll pick the first one I saw. So the point, check. How do you get the slope? Rise over run. Good old right. Y2 minus y, it doesn't matter. So 2 minus -1 is 3. -1 minus 2 is -3. Now hopefully right there, if you came out with 2, how do you know that ain't right? Looking at the picture, it's got a negative slope. Right? So you shouldn't come out with anything positive here. It certainly is going down. So I want you to realize something right now. When we get involved in even funkier stuff, we learn different functions. There's going to be parts of these problems that are this. This stuff, of course, never goes away. There's a purpose. There's a reason we learn this, because it's useful later. So don't overthink this kind of thing. Say, oh, that's an algebra piece. That's fine. Don't think, oh, that's new stuff. Oh, crap. We're going to have a lot of little parts where it's old stuff. Let it be old. Let it be easy. We've got a lot of hard stuff enough to do. So now you can do your favorite, however which way you want to do it. You could use this directly and just solve for b. Y is 2, m is -1, x is -1. I can solve for b. The funny thing here is, I think they show this. You can pretty much see the y-intercept right there, can't you? I mean, I could have used that point, but I wasn't absolutely sure. But looking at this, that's how it's going to come out, isn't it? B is 1. Cool. So what do I put here? What is it doing in that middle region? What's the function? Yeah, mx plus b. -x plus 1. So there's a gimme. I like my really smart students that I can see they took their homework out and they erased whatever they tried and then they just put this right there. And I don't blame you, man. I just get a whole problem for you. I love it. I try not to do that too often. Yeah.
Can you explain 1 and 2? I mean, 1 and the negative 2?
For any output in that first region, what's the input? For any output, input, what's the output? If I input this x, what do I get as an output? If I input this x, what do I get as an output?
Oh.
It's always 1. So that's a constant function, right? That's the good old y equals 1. That would be a horizontal line. So both of those are horizontal lines, so both of those should be constant functions. Nice and easy. Cool. Why wouldn't they give you this as an example to do here?
Because that's x.
And more specifically, it's not a function. It's like the worst thing taking the vertical line test. You failed this thing miserably, dude. And a vertical line hits it everywhere. So it totally fails the vertical line test. Cool. All right, so that kind of thing where you have to find the equation of line is going to happen very often. And it's going to continue to happen if you're a math major. You're going to have to find equations of lines. And as you get further, you'll have to find equations of quadratics and cubics, quartics. Yes?
Why is it x plus 1 everywhere?
That's the equation we found for the line, right? Putting this back together, what was the m? What was the slope? Negative 1. And what was the y-intercept? 1. So that's the function we put. That's what it does in there. That's the definition of that line. That must be the function that it uses in that middle region. Cool. You should expect, you should know, if I gave you one of these problems, I would probably give you at least, more than one interesting line, if not something a little more interesting than that, but we'll see. Won't make it too crazy difficult, but you got to know how to find equations of lines pretty quickly. You should go, oh, thank God, it's just a stupid line problem. No big deal. If you're not there yet, then come see me soon. Yep.
I'm having a hard time remembering the other equation of y.
Oh, yeah. If you wanted to, you could do this. Which is really just, the funny thing about this one is it's taking this guy. Don't they look very similar if I multiply that up? And saying, does it matter what the second point is? A straight line, it doesn't matter what the second point is. It's going to be the same slope no matter what. It's going to reduce to the same number. So I just take those away. So it can be whatever the hell point you want. And I just multiply that up, bam. So this equation comes directly from the idea of slope.
I have a question about 2a from quiz.
2a. Oh, yeah. What's up?
In the end it says solve. You factor out the equation and x minus 12 and x minus 4 is 0. Wouldn't it be x 12 x?
Oh, yeah. So there are a couple of different mistakes made. 2a, everybody had a radical in there. And I think we looked at this, and I actually made a really pathetic joke about it. It was sort of like tyrant class. You isolate the radical and you kill it. So the very first thing you have to do in there is like -1 or -3 or whatever the number is. You've got to get it out of the way. You cannot just... and the mistake a lot of people made is really related to this. I mean, what should that be? What am I squaring? 5, so I should get 25. But if I do 2 squared plus 3 squared, I get 13. And of course it's because squares are not based on addition. They will not play well with addition. They cannot distribute across addition. But that's what we all did here. A lot of us, we did this kind of thing. And we just said, okay, that's x plus 1. And some of the guys left it minus one way or the other. And you got to here. And then it ended up some funky ass thing. It's the same exact mistake to make. It's easier to make the mistake when there's a variable. I'm not trying to come down on you if you made this mistake. I understand why you made it. You're like, why would I foil it? I don't want to foil it. Well, it's too bad. If you do this, you have to foil it. So don't do this to yourself. What's better? Get that thing out of the way. Now, the mistake you're talking about is whenever you have a square root or any radical in an equation, you've got to check your answers. Anybody remember the word extraneous? Anybody ever heard that? Extraneous roots. Where the math says, here's the answers, and then you say, no, that one doesn't work. And then we hate math for that. We're like, math, what the hell? You gave me a wrong answer, you punk. Well, what's actually, let me see if I can make a quick example. Oh, Jeff, you can do it. Okay, there. Right, so to do this problem here, you first have to add the 1 over. And then you square. So you get x equals x squared. Foil this bad boy out. That's the other mistake. I saw a lot of this kind of thing. What did they lose? The middle term. Yeah. So minus 6 is minus 12. Right, so if you need, you can write that thing out twice. And now you suck the x over. The idea here now is to get it equal to 0 so I can try to factor it. And then I try to factor that thing. See what happens. So what do I get when I factor that? That one's not too evil. Four and 9. And they both have to be negative. So x is 4, x is 9. Well, let's see. Does 9 work? Square root of 9 is 3, minus 1 is 2. 9 minus 7 is 2. It works. What about 4? Square root of 4 is 2, minus 1 is 1. 4 minus 7 is negative 3. Shit. So why did math do that? Scumbag math. 4 is gone. 4 can't be any part of it. You've got to check your answer. So why exactly did math do that? Because when we square both sides of this, we lose information about if it was negative or positive. When we square something, it comes out positive. So math, now look, when I plug a 4 in, don't I get a 2 here? You with me? Of course. But what if it was negative 2? We lost information about whether it was 2 or negative. If it is negative 2, isn't this true? So the math gave us this answer because we did something that hid what was going on before. So the math said, well, from here, it looks like the answer is this. And we got to go, shit, does it work in the beginning? Because I did some funky stuff here. I killed any negatives that might have been there. Or maybe. I like to explain why this, because I know this is where I start to really lose students when I'm teaching like algebra. They start to go, okay, not only is it hard, but the freaking thing is lying to me. I'm not going to understand that. I'm like, math's supposed to give me the answer, and I stop, and what the hell, Jeff? So I like to tell them, this is the trade-off. Squaring made it possible for me to do this, but it made math lose information about what was going on before. Yeah.
So what type of problem is it that we need to check both answers?
So the type of problem would definitely be anything with an even root. Because I don't know if you remember, odd roots don't care about negative or positive, right? So even roots, radicals, and of course problems like this, blah, blah, blah. Because I couldn't get, for example, I can't get 1 or 3. So if I get either one of those, I have to throw it out. So those kind of things. Cool. Yes, sir?
Did you number 45 on that same slide back?
On 2-2?
Yeah.
45. Oh, so that's the one, sketch the graph of the piecewise?
Yeah. I just got an answer compared to the book.
Does everybody understand that problem? Now you got basically a format to follow when you go to correct yours. Yours has a little more stuff in there, but it's the same idea. Okay. This is still page 160. So what shapes do I have involved here? I've got flat line, horizontal line, constant function. I've got parabola there, and I've got another line, down line, right? Okay, cool. So it's good to know ahead of time what to kind of expect. Yes, sir.
Can you just give more examples of that? Like why, like straight lines, like when you see that you think of a straight line, or a upside down horizontal, or slide line?
Well, here I know that this has got a down slope. And I know it's linear because it's the first power. So that's all I'm looking at. The minute I've got anything on my variable that's not a first power, I've got some kind of curve. Cool. And of course, squares we know specifically any even powers parabolic. And this guy, of course, is a flat line. I always like to think of this as being describing the height of that calculator over time. It's 4 feet. It's 4 feet up there. It's 4 feet. Yeah, that's very boring. Right? Nothing happening to the thing, right? So you guys kind of with me? Okay.
So pretty much the same y equals 4, y equals
Exactly.
1, y equals
So if you want to, there's nothing wrong with saying y equals 4, make a little xy table, y equals x squared, xy table, y equals negative x plus 6, xy table. I think this is how I showed you how to do it. I would love, now piecewise functions are the one place I allow tables because it's piecewise give everybody some trouble and it kind of helps us feel a little more comfortable. We know XY tables. You should definitely know. I would rather you not use XY tables anywhere else than here. You should have other ways to graph things quicker instead of having to plug points and go. Right? Hopefully. So, where is this true if x is less than negative 2? So, who remembers when we did an example like this, what values, obviously you can only use values that are less than negative 2, but what value do I actually want to definitely kind of start with?
0.
Okay, a couple things wrong. It's got to be less than negative 2. I'm not allowed to throw anything in there that's above negative 2, with me? Or equal to negative 2, exactly. But I still want to throw a negative 2 in there. Because what's going to go there? Open circle. And if I don't put it in, I have no idea where to put that open circle. You guys with me? And that's why, you see, I put it in parentheses telling me, oh, that an open circle should go there because I'm not allowed to really be there. This is my own little thing I do for myself, but obviously I think it's a good idea then. But if it makes sense, do it. When you throw a negative 2 in, of course you get 4. And of course here, I really don't have to do any, I shouldn't have to do a table, really. It's just 4 everywhere. Everywhere it's allowed to be. How are we doing so far? Sort of. What about here? That's only this between negative 2 and 2. So I can plug in negative 2. If I need to plug all this in, I can. Right? Those are all the things I'm allowed to use, all the whole numbers in there. Integers. So this is not too bad, right? 4, 1, 0, 1, 4. Everybody all right so far? So these piecewise functions don't make a huge deal out of them. The thing you have to be really careful about is these boundary points. That's where something ends and something else takes over. So over here it looks like this line. I definitely want to put what in? For sure. 2. I want to investigate what it wants to do at 2 so I know where to put the open circle. So at 2, where does this want to be? 4. And then it's allowed to be at 3 and 4. So at 3 it's 3. At 4 it's 2. Cool. Alright, so that's exciting. Let's finish this out. Oh yeah, let's finish this out. And again, if you're ever bored with what I'm doing up here, you've got the corrections to the quiz and the homework to finish up and the practice tests to try. You got stuff to do. Let's see. Okay, cool. Now you just start to attack this thing. Negative 2, 4. And of course there I just draw a straight line, a flat line, back, because it's allowed to be less than negative 2 inputs. So the interesting thing about that open circle, what does that middle part come in and do? Doesn't happen all the time, but now I want to start to graph this in the middle. So it's going to be graphed from here to here. At -2, it actually is at 4.
Why is that? Why is it at 4 and not -2? That's my question. For some reason, when I'm drawing the parabola I'm just getting the idea where the parabola stops at -2 and 2.
Yeah.
Not continuing up to 4. That's where I'm.
All right, so we got two things going on. We have x tells me where I'm allowed to be. Y is just what comes out for those values. So my x's are allowed to be between -2 and 2. My function could go to infinity if it feels like. But I have to stay in here. Nothing said I had to stay in here. These are y's, x's. Cool. So my x's can only go from here to here for the parabola, right? X's have to be between these two for this. But my outputs can do whatever the hell they want to do. Right? I can go up as high, as low, whatever. So sure enough, at -2, my parabola is here. And then at 0, it's 0, and then at 2, it's 4. Okay, it's supposed to be symmetrical. Telling things. Yes, ma'am.
With that piecewise, since it's an open circle for the anything under -2, is there any way to show that on the graph that it's like both
Not really,
of them?
because that other one comes in and fills
Still
it
is
in.
filled in. Okay.
Yeah, and that's not always going to happen. All I had to do here was make this y equals 5, and this would have been here, and this would have started there.
I understood.
They would have been separate then,
Yeah.
but they just chose to fill those in. Because what happens on the other side now, kind of unfortunately, the line takes over, and it would have an open circle here, but it's already filled. And what to do from there? 3, 3, 4, 2, so now it's a straight line from there. Yeah, so you make that open circle, but if the other guy comes in and fills it, or if that open circle is on top of one that's already filled in, you don't have to show that it's open somehow. It's not, it's been filled in. So this could be somebody, I'm walking along and all of a sudden, holy crap, it fell, oh shit, and I roll up and then I'm like, I don't know what this is. But this could be something physical. The minute I've got the open circle doesn't get filled in, now it's really difficult for that to be something physical. I'm walking along and suddenly I teleport 3 feet down. And then I'm like, oh, that was neat. See, so in order for this to be really something truly physical, it has to kind of fill it in, so it remains what's called continuous. So if I have a graph like this, which I certainly could, well, that's free. You know. Well, the missile went here, sir, and then it teleported itself over there. You know, I didn't know the missile could do that. All right, I'll always hope. Yes?
Did anyone see on the quiz?
1C?
Yes.
So is everybody cool with that? I mean, this is what to do for yourself when you hit a piecewise function. Just tell yourself what you're allowed to use and set up tables for each one. Tables should definitely be old news for us. Hello?
No, this is from the quiz is 1C. Oh wait, well, he is making up stuff. I know, I'm sorry.
You said you don't want to give us exact numbers.
Well, there's two reasons for that. One, there's 4 different versions of the quiz, so who am I going to be nice to? And secondly, I want you to be doing the corrections, not me. But this is the same kind of problem, isn't it? It's actually a little worse, because I've got 3 variables up here. There are only 2 in the quiz. For the most part, this problem, if I remember correctly, went okay. A few people subtracted these. See, so we get mixed up, and I'm teaching Math 88 and teach Math 90, and I really try to hammer this home. Exponents are not numbers. They're not. So when I have a student make this mistake, and what mistake did they make?
They square root it, so it's
Yeah, they squared the 3. So when, and I tell them, there is no 3 in here. And then they look for my medication. There's 3 right there, Jeff. You stupid. I'm like, no, this is not a 3. What is this? There are 3 A's. That's all. There's no number 3 in there. There are 3 A's that I designate with this symbol. So there's no 3 in there to square. So a lot of the mistakes we make with exponents, and then even we start to go backwards and make mistakes, we do things like subtract these. And why do you think they do that? Because the property of powers is subtract when you divide. But division of numbers can never suddenly become subtraction. Right? Mathematical rules cannot suddenly change. It's just that they're going to act differently with exponents than they do with numbers because exponents are not numbers. They have to act differently. All right, so there were a little bit of that kind of thing going on. What am I actually supposed to do here, though? I want to hear somebody say it. Yeah. Reduce it. Love it. Simplify it. What goes into both? 7. So you get 2 over 11. What can I do? My suggestion is, and I think a lot of you guys do this, is to move the negative powers because it does, believe it or not, make it easier. If you don't like doing that, cool, don't do it. Do it whatever way works. But if I do bring that up, how many A's will I have up top now? 8. So a few people would bring this up and forget there were 2 already there or something, you know. So there's 2 there, 6 more coming, I got 8. So I can tell myself a little story as to this problem. There are 3 B's here, 3 more coming. 6. So a lot of people canceled these. But of course, it can only cancel, my shoes will not sit there. It will only cancel if they are the same. And B cubed and B negative 3 is not, they're not the same.
I think you were getting mad when you corrected mine.
What'd I do?
You wrote it. Not the same.
Oh, okay, sorry. I think
You
that
were
might have
getting
been
frustrated.
the 28th one I did. I'm like, come on. Are you guys so far so good?
So far, so good. So if what you were just talking about, can you cancel out the negative exponents on the C then? Instead of just switching
You
them?
definitely cannot do anything directly like related to like canceling negatives or something. But these 9 C's want to go where?
Up,
Up. And those 7 C's want to go where?
down.
Down. So how many C's do you actually have then?
2, up.
Yeah, 2 up here. 7 of them cancel. And you can see it in your head. There's 9 C's. I'm not going to do 9 C's. And there's 7 C's. 7 will cancel. There will be 2 left up here because that's where more of them are. So personally, I kind of, this is 9 minus 7 is 2. I know the rule is subtract when you divide things with powers, subtract the powers. But it's so much easier if I have this to just think to myself, well, 3 cancel, there's 5 left on the bottom. There you go. I don't have to do b to the negative 5. Just 1 over b5. That's where they are left over. So here I've got c squared up here. Okay. Yeah, so now do the 2 things that the power tells you to do. I will not say that this is negative 4. A negative power can never change the sign. All it means is flip. So I flip it, and then I square it. And what happens here when I square? 12, good. For a 16C 4. So is that one all right? So that's sort of how you attack. If you've got to make corrections to 1C, that's how you do that.
Well, me, I know you worked it like 3 times already now. On 2A for quiz, doesn't tell me what version it is, but the one with the radical plus 1 on blah blah. My last term disappears, and I'm like, for some reason it's not there. Is it
Oh, it's
supposed to
fine.
complete the square?
No. So you're talking about you get to a point like this.
No, my last, the 3 just, oh yeah.
So you subtract the x, subtract the 3, you get the 0 on that side, and you get x squared minus 8x, and that goes away. This is an excellent place to be. There's not 3 terms, so you don't try to do binomial. What is it you always try first when you factor?
Oh,
GCF.
take the,
Yep, take out an x. Then either x is 0, done there, sweet. So it's really nice when a GCF comes out, you're done with that piece. Or x is 8.
thank you.
You're welcome. So it's funny, in the past I've had people like on some versions, your number didn't disappear. So it's really funny, they would say, well, that's not fair, they had an easier problem. Well, no, because a lot of them missed this. This is a very easy problem to miss. Because you're not used to thinking about GCF when you have this kind of problem. You're used to thinking about binomial. Yeah.
Practice test 2C.
Oh, yeah. Let me see. So we got this here? You want it? Okay there. Yeah. So 2C. This one here. Yep. Okay, so what do these mean? On the test, it's easier to tell what those are. Absolute values. So inside here, of course, what do you get? 7 minus 8, which is negative 1. So that's what you get on the inside there. Plus 12 over 3 times negative 4 is 12 divided by negative 12, which is negative 1. So what's the absolute value of negative 1?
1.
Put a negative on it. What's the absolute value of negative 1?
1. 0.
So on the board, my absolute values don't look all that great, but I think you guys look at that. It's pretty easy to tell, right, that those absolute values. They're really thin and they're longer. So it doesn't say negative 17 something or other.
You have answer before this?
Yes. In fact, let me give that out before I forget. Make sure you got a front and a back to this.
Well, I was just reading practice quiz on those that things to do, and that's just one of the homework, but not having answers. When is actually good?
So take a quick second, make sure you got a front and a back. My printer really likes to mess with me. Evil printer demon, yes. Oh, I didn't bring any blank copies. I did. I don't have any with me now, sorry. But it's up, I can email it to you if you email me. I can email you a blank copy. Or if you got a minute, you can come to my office. All right, so real quick word of warning about this. If you're going to do the practice test at all, one way to do it is just do it like it's a test and kind of even time yourself maybe if you want to. and then double check against this and see what you got wrong. Do not, agreeing with me won't teach you anything, right? Yeah, Jeff, good job. Yeah. So don't do that to yourself, because I've had students do that, and they come in, they said, I looked at your practice test, and I looked at it for a long time, and I was seeing what you were doing, and then I failed you. I'm like, no, you got to do it yourself. All right, so don't even try the problems more than like 3 times. If you're doing a problem, you erase it, do it a problem, erase it, do a problem, don't look at it again. You're going to get way too stuck on that problem and not understand the idea behind it.
Oops, my bad.
No, sorry. Math needs musical intermissions, I think. Okay, cool. Yes.
For 6, when it's the 0 for function, we just equal to 0, right?
Exactly. So 0 is another word for root of something, and that means where does it cross the x-axis?
Yeah, we just equal to 0. And so
Equal it to 0, exactly. Real quick, 6F and 11, I think those are the ones that are from section 2.7. So 6F and number 11. 6F is not just reciprocated. 6F is called the inverse function, the opposite function. So it's the function that does the opposite of what the original function does. And that's what we're going to learn in section 2.7.
And 11, right?
And 11. 1 to 1 has to do with if it's invertible or not, if you can find an inverse. So that's in 2.7 also.
On the correct, going back to the corrections. Can you come and see this real quick so that I know what to start from?
Yeah, I should.
I'm just gonna be part of my stuff in education.
Yep. Just remind you guys, if you did a lot of work on a problem and you didn't make a mistake until like the second to last step, you can start where it was last good. You with me? Just pick it up right there and do the right thing from there. You don't have to redo the whole problem. There's really nothing to gain there. You obviously kind of know how to attack it at the original. You just didn't know how to finish it out. So you guys know how to factor a difference of cubes? Yeah?
Let me do it.
Let me help you guys out. I'll ask myself some questions.
Oh yeah.
This is one that kills my, in fact, I don't care what class is it. 180, 280, 281, 178, everything that's supposed to have seen this factoring stuff already, they hate me. They said, you put a cube on this problem. I'm like, yeah, I did. What the hell? So you've got to know this. Trust me, if you're a math major, you've got to know how to factor all the different forms. Make it even more interesting. No, let me just keep it basic. So remember, which one is more laid back? Which one is not so uptight? A square root or a cube root? Which one is like whatever, dude? Cube root. The odd roots have no problem. The even roots are like, you must not be negative, and they're very uptight. So I can do difference or sum of cubes, and that is actually very related to the fact that I can do cube roots of positive or negative. Whereas I can't factor a sum of squares. Right? I just can't do it. So how in the world do I do this? On the side here, let me say something real quick. If I had this, how would you factor that? Not 3, Jeff. Not 9, Jeff. I'm one step behind myself here. There we go. Yeah, you just cut everything in half, multiplicatively, right? 9 is 3 and 3, W, 3W, plus minus to make sure the right stuff cancels. And then cut this in half, cut it in half, you're done. You cut it in half because there's 2 of everything. Nothing too amazing there. So over there's how much of everything? So I'm going to somehow cut it in thirds. But it is not, you can't do it like this, because then you get a lot of cross terms that you just can't do anything with. It has got to be little dude, big dude. Right, that's how I teach cubes. Little dude, big dude. And it's going to be very much like this. Instead of cut it in half, put 1 and 1, cut it in thirds, put 1 and 2. So at the end you end up with 3. So what the hell do I mean by that? Well, this is 3W, 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 right? And this is 5A, 5A, 5A. So yes, you should know some cubes of things and how to break it down. So in the little dude, he's a little tiny dude. You can only take one of each. So you put a 3W and a 5A. So what's got to go here? So that in the end, you end up with 3 of these bad boys. Well, the other 2, 9W squared. Right? So it's a lot. It is actually more like this than you think. I put that there and that there, so together they make the 2 like it used to be. Well, I put 1 here and the other 2 of each there, so overall they make this at the end. So at the end here, what am I going to put? Yeah, the other 2 of these, 25A squared. Now, real quick, you could ask, why the hell do you need shit there, Jeff? Well, a really good answer is, I do get my 27W cubed, I do get my 125A cubed, but I also get 45 freaking AW squared. Do I want that? No. And I also get plus 75 A squared W. I don't want that either. So that's why this guy is the opposite sign, because he's got to cancel some shit out. Right? Oh, sure. Opposite sign. And the thing that's going to work is this times this always. Multiply the 2 pieces of the little dude together. So 1 of each, 2 of each, product in the middle. Make a little song if you want. What kind of songs in math, believe it or not? I don't like them personally, but I won't. So what's got to go here then?
15 AW.
Yeah, 15 AW or WA. But alphabetical or not, I don't care. So now look what it does for us. What's 3W times negative 15 AW? Negative 45 AW kills that dude. Right, so that middle dude is the cleanup dude. He kills the stuff I don't want. And then of course 5 times this will be negative 75 A squared W kills that. So I do end up with just what I wanted. Okay. How do you guys feel about that?
Can you repeat how you got the 15W?
This here?
Yeah.
Just this times this. So the opposite sign, and then multiply these together. So here, you guys try this one. Now I'll throw you a curveball, of course, when I make you do it yourself. Minus. Oh. What do I do? I'll make it minus.
Isn't there a slope to remember the sign?
Say again?
Isn't there a slope to remember the sign?
Soap?
Same, opposite of all these positive?
Oh, I like that. Never heard of that. Same. So this would have been a minus. This would have been a minus. This has to be the opposite. So same, opposite, always positive. So, I like that. Go ahead. Corey's good for that kind of stuff.
Yeah.
Yeah. I like to kind of do some memorization, but the more you memorize, the less you remember why it had to be that way. So I really like to explain why must it be that way. But soap is good too. I like that. It's a quick. Just make sure everybody's on the right track. This was 3W, 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 because that was W cubed. If I have x to the 6th, I got to break them down into 3 what's? X squared, x squared, x squared. You just really do cut it in thirds. Right? Be 2x squared, 2x squared, 2x squared. What's up? So really, I mean, as long as you remember the format, the minute you have those broken down like that, they just fall right into place. Right? One of each, two of each, the product in the middle. So in the little dude goes what?
2x squared.
Yeah, one of those.
And,
Minus
W cube.
one of those. Good. So the big dude now has to go
4x.
4x to the 4th. So you can kind of check yourself. You got your 8x6. So far looks good. At the end would go W6. The middle, what sign is it going to be?
2x squared W.
Plus. Multiply those.
2x squared W.
Exactly. Cool. I love it. Yeah.
How do you know what's going to be better?
Say again, sir.
How do you know if it's going to be plus or minus?
This is going to be the opposite of this, and this is going to be the same as that. Cool. And do you see why that last term has to always be positive? Because if I want this to be negative and that's already negative, he's got to be positive. Over here, it's already positive. It's got to maintain that sign. It doesn't want to change the sign on that last dude. So here's another way to look at it. There's only one negative in the whole thing. It's either here, like this, or it's here, like that. Yeah.
You're just bringing exponents over for the 2x squared w, or just bringing it over. from
Multiply these
the
together.
No, I get that, but I'm talking about that stuff.
Yeah, because you got to multiply 2x squared times w cubed.
So is that gonna be always? Are you always just bringing it
Always.
over?
Always the product of those things. Good. Okay, cool. How do you feel about that? So if I were you, I would do a few, and then maybe about half an hour before the test, I'd do a few so it's like in my head. Because it's just, the reason that people don't like this as much is because it's one of the only ones you have to kind of memorize the form. The other factor you can kind of attack. Yeah?
Does it ever work out that you can reduce the second?
No, I'm glad you said that. You can never, ever factor this. The funny thing about this, unless you left a GCF in there maybe, right? But the neat thing about this is it's always half of what it would have to be for this to be factorable. Always. So the big dude, you can never, ever factor the big dude. So in some of your quizzes, on number 1B, there was a x squared 4x16. That was the big dude for the cube that should cancel out. Yeah. So don't tear your hair out if you get a problem like that and you can't factor a trinomial. Maybe it's the big dude somewhere else that's going to cancel. Yeah. Don't waste time on the big dude.
Like this, for example, we can factor the small one, right?
This here, can you factor that?
Like in different example, like if it's like 4x squared minus w, like 4.
Yeah, if it did come out to be that way, then yes.
Yeah.
You're right. You could do it. You could factor this piece. Yeah, I like it. But you can definitely never do the big dude. Okay. Yeah.
30 times 21.
Oh yeah, good. This is kind of the last way they could throw a piecewise function problem at you, and it's actually the first